Welcome to DfRSoft's tutorial on environmental profiling. I'm Dr. Alec Feinberg, and we're going to talk about today what do you do when you have products that are exposed to time-varying stresses, and how do we decide what is our use condition. This complicates things when we have various profiles in the field. And what temperature do we use, for example, for making a prediction if we have many different temperatures exposed in the field? We're going to use the method called environmental profiling that we use in DfRSoft. And this only other thing I've heard is a method called CALT. The DfRSoft method is very simple compared to that. So let's get to it and see how that works out. So we double click on our application, and the DfRSoft opens up, and we see our tools here, and there's a lot of different tools in DfRSoft. So we're going to see that today. So let's hyperlink to our menu here. It's just the next. You can hyperlink or tab it. It's the next tab over. So here's the hyperlink method, and you see our open style menu. And we have a lot of reliability tools, field returns, system reliability. There's all the tools. It's a very open style menu. It's very easy to find things in DfRSoft. And we're going to look at a lot of these tools today. Quality area, we have lot sampling, design of experiments, availability and sparing, engineering tools like thermal analysis, shock and vibration, corrosion control, and our physics of failure library. So it's an awful lot of value. So the environmental profiling is module number 9, and you can the modules are labeled down here. So we're going to tab over to that. We're going to hyperlink rather, and here we are. And so let me zoom in on this here so we can see what we're doing. And so DfRSoft has the ability to do environmental profiling for temperature. Next to that is your temperature cycling module. So you can do that for temperature cycling, and you can also do that for shock and for vibration, as well as temperature humidity. So the first thing you'll see in the let's do the temperature first because that's the easiest. Now, if you don't know how to do the model is provided right here. You can hyperlink to that. There's this video that we're looking at right now. Plus, there's pop-up instructions everywhere. Down below, here's a very detailed pop-up instruction that you can look at. That's describing. I can show the comment, and you can zoom out and see that comment. Very detailed. So. A lot of help in DfRSoft, so we very rarely get people asking us how to do things because we have the videos and the pop-up instructions, and it's right near where you're using it. It's very convenient. So what I've done is, let's say that we have a product that's in the field from varying between 30 degrees C and 70 degrees C, and I've broken it down into 10-degree increments. And let's say we want to design our accelerated life test for 10 years. And we know the percentage of the time that it's at each environment. Now in DfRSoft you enter things in the green squares, and the results are nearby. So the results for this are down below. So we're going to do that first. So I have that, and now I've added, we know it's 10-year time, so I know it's 5% of the time at 70 degrees C, so I multiply 5% of 10 years, and that turns out to be 4,380 hours. And so, for example, 30% of the time it's at 40 degrees C. So that comes out to 26,280 hours. And then once you do that, when you fill that out, the next thing we want to do is put in our activation energy. We're using the Arrhenius model. The model, you can hyperlink to it. And down below is our results. And the first thing you'll know is it gives you an equivalency for the high and the low temperature that you entered. We entered 30 to 70. So it says that at 70 degrees C, this would be equivalent to, if you were just at 70 degrees C, the whole time it would be equivalent to 19,000 hours. Where if you were at 30 degrees C, it would be equivalent to 440,000 hours. Now the next thing we want to do is we want to say, well, what is it Give us a temperature that is equivalent to what temperature would be roughly 10 years for this. So I happen to have played around with it. I'm going to put in 49.5 to show you that. And remember, you enter things in the green squares. I press return, and it says that's to within a half a degree. I happen to know that this is the closest equivalent to 10 years. 49.5 degrees is the closest to 87600. So we're going to say that our use temperature is 49.5. So that means that all these temperatures, the whole profile for the 10-year equivalency of all those temperatures is 49.5 degrees, would be equivalent to 10 years of for that one temperature. Now the next thing I want to do is I want to figure out what my accelerated test is. So I happen to want to do around 1,000 hours, and I happen to know it's roughly 120 degrees C. So I'll put in that. You can see that it's 964 hours. And so I basically have designed my accelerated test. I know my use condition and I know my stress condition. Now let's figure out what our acceleration factor is. Remember, we're using the Arrhenius model. So the next thing we want to do is we want to look at the acceleration factor page. So we go back to our menu and we go to the acceleration factors, and it's right here. We look for the Arrhenius model. It's right there, and we click to it, and there we are. I've already put it in. 0.7, 49.5, 120 degrees stress, and it tells me that my acceleration factor is 91. So now I have my test plan for 91. So I have an idea of what my acceleration factor is. We're ready to do a test plan. So let's do a chi-square test plan and see how many samples we need. So we go back to the menu page and we look for our chi-square test plan, and it's right here. So let's do that. We're going to hyperlink to page 8 in the DfRSoft module 8, and we go over, and let's say we want to know what our sample size is. So right here is our sample size calculator for a simple test like just temperatures testing, and we know our acceleration factor is 91. So remember, we enter things in the green squares, and so we're going to put in 91 here. Our confidence level is 80%. We'll say we planned for 1,000 hours. Recall that's what we're going to use. Now we need a test objective. Let's say we want 500,000 hours. So that tells us that if we plan for one failure, that tells us we need a sample size of 16. If we were just planning for zero failure testing, we would want 9. What if we wanted, say, 1,000,000 hours? What would that be if we wanted to verify 1,000,000 hours? Let me just do that one. That says we would need a sample size of 18, or if we wanted one failure, 33. Now, so that gives us an idea of what our accelerated test is. Okay, there's a few more things that we would want to do. We can look at other distributions, for example, other than the chi-squared. First, I'd like to mention that some people like to design testing by looking at the probability of mission success. You can do that. We can hyperlink to that area here, and we can go to that's on our first page on conversions, and there's examples how to put in the data. And we had 1,000,000 hours, so okay, so let me put that in. I think I didn't do that quite right. Okay, and then we can put in, say, 5 years, equal to 5 times 8,760, and go across that line right there for the 5 years here, and we can see that we would be about 96% successful for 5 years, or 4% failure. So what that would mean would be that we would be 80% confident that we'd have no more than 4% failures in 5 years. If we had a successful accelerated test, it would be an indication that that's what we have demonstrated. Now, going back to looking at other distributions, we had used the chi-squared. Some people want to use, say, the binomial or something like that, because the chi-squared is an approximation, and it's a very good one, I might add. But so we can hyperlink to that, or let me just show you through the menu. The binomial is listed under the chi-squared section that we were just at. It's actually at the bottom of the page. So this is the module for that, module 8, and it's at the bottom. So we can hyperlink to that module. And so here's the calculator that has a few other distributions that you can look at. And let me put in the scenario that we had. We had 33 samples, 1 failure, 80% confidence, got the acceleration factor there and the test time. And I'll put in the 5 years, so 5 times 8, 760. And we were doing single-sided. Whenever you do chi-squared planning, you're doing single-sided analysis because you're looking at upper bounds on the failure rates. So now this says here's the results that we want to look at, this comparison between the two, and we can do that. So this is the area. We have about 8.8% failure versus 9% failure for the chi-squared, about 1 failure per million hours for the binomial versus, again, this is 0.967 versus 0.997. And mission success 95.6 versus 95.5, and that's a pretty good comparison. And we don't have a very large, we have a kind of a large sample size rather. So let me put in, say, 9 samples, and we'll seem to get a little bit more discrepancy. I'll put in 0 failures, so here we have 16.37% failure for the binomial versus 17.88, and the failure rate 1.8 versus 1.96, so a little more discrepancy now. Probability of mission success 91.7 versus 90.95. So you can see that the chi-squared is actually a very good approximation, even in somewhat on the low sample size areas. Now, one other thing we wanted to talk about was what happens if you have other stresses and you want to do a more complicated accelerated test plan for other stresses like temperature cycle. And that's what we're going to talk about next, and how you would do that in DfRSoft. Okay, so now we're going to talk about complicated test planning for multiple chi-squared kinds of tests which involve different stresses. And so we'll go to the menu area in DfRSoft, and so the area that we were in module 8 before, and we can stay here. There's a 2 methods here: the test plans for the chi-squared method, and also there's the automated qual plus test plans. We're going to first do module 8. So let's go there. We were in this area here. Just below that is the area where you would enter your multiple chi-squared failure rate analysis test planning. And the first thing you're going to want to do is to fill out the area of the laboratory conditions for your tests. So that's in here. Remember, we've filled things in the green squares in DfRSoft. And there's lots of help, plus videos like this for this section. And so, for example, this is a compact method rather than going back and forth from the acceleration factors to the chi-squared calculators. This is all encompassed. So this has the 4 main tests that our people do. And for example, the HTOL is in this line right here. So the test duration is 1,000 hours. The use condition, if you remember from environmental profiling, was we had 49.5 degrees C for the 10-year use condition, and the laboratory test temperature was 120 degrees, and we're using 0.7 EV activation energy. And then to the right, after you've entered these, notice there's pop-ups that help you to know what industry standards are for these parameters, the key parameters. The temperature humidity one has 2 parameters. You can see that, and 2 conditions for temperature and humidity. So the acceleration factor to the right, remember we had 91, so this finds that as well, so that results is provided, and now we are down below. We can start looking at our sample sizes. First, we put in our confidence level. 80% is what we were using, so roughly we had, I think it was 33, but this one we have 30. We put in 33 here, and what this does is you can put the sample size in. If you're coming up for a total test objective, you can play with your sample size until you meet that objective. You can go back and forth to estimate what exactly is the best sample size for each test that you feel is warranted. And DfRSoft, you can also put in the number of allowed failures and the duty cycle in the field that it would be using. Even though this is a test condition, we would use the same duty cycle. And it provides you the results, the chi-squared results, the fits or the failures per million hours obtained per each test, and the roll-up for that, and the failure rate percent, as well as the total fits here. And also to the right of this, I mean, you can go back and forth with sample size. It's difficult to know what is the right sample size. So DfRSoft does, if you have one test objective for the overall test, let's say 2,000 fits, this is our optimization calculator, and what it does is it finds the minimum sample size to satisfy the test conditions that you're interested in for that total requirement, in this case 2,000 fits. And recall, if you don't know what 2,000 fits is, you can go to the conversion tab, which is number 1 down here. We can go over that and put in 2,000 fits, say, and that would give us an MTBF of 500,000 hours. So going back to the test plan, here we are, and I have 1 failure allowed for each one. We could change that to 0, give you an idea of what the reduction would be, and sample sizes is shown here. Total sample sizes needed for the test is 81, and the fit allocation that is provided. So this is one method, and also we have the hyperlinks to the test summary. So the test summary is provided just below this area, so you can see the test summary, and if you're interested, it gives you all the test summaries and the stress conditions. Also, it gives you the reliability, so if you want to plan for probability of mission success, you can do the roll-up is right here for 1, 5, and 10 years, or you can put in any time that you want for the mission success that you're interested in, and it gives you that. Now, the next thing we're going to do is we're going to, let's say that you don't know very much about accelerated test planning, and you want to design an accelerated test more related to industry standards like JEDEC. So DfRSoft, you go back to the menu, and it has automated test planning. And this does 2 things. It not only helps you with, we'll hyperlink over to this section. This does a couple of things. It keeps you consistent with your test planning. So it's a methodology that helps you maintain consistency with what you're doing on your accelerated testing. And not only that, but it gives you, there's a lot of intelligence that have gone into these sections, not only just to make things easier for you to understand and be able to be successful doing design assurance on your job, but you should see how DfRSoft is working the issues, and you can refine your test in accordance with some of the intelligence that we have that have been years of understanding of accelerated testing, and use that wisdom we're providing for you. So here we have this, you can choose whether you want to do a semiconductor plan, hybrid, or assemblies. So let's choose assemblies, for example. And in this case, the input is slightly different. It still gives you the output for each, but the inputs will be slightly different, tailored to which one of those you're doing. And there's a video on this, and of course there's the pop-up as well, instructions as well as a video. And that's another good thing about DfRSoft. There's like this video here, there's an awful lot of things that you can learn right away from DfRSoft. So here you put in your initial information about the qual plan, who's doing it, what the date is, and things like that. Your objective, let's say it's 1,000 fits, 80% confidence, and we're going to plan for 0 failures. Then you come into the stress areas and you start filling out the stress conditions. For example, the high temperature area, we had 1,000 hours. The test temperature, I think we used condition, we had about 50 degrees C, and the maximum, rather the test temperature was 120, and the maximum use condition, well, this relates to your junction temperature too, but we had about 50 degrees C, so we'll put the junction temperature down to 0 to maintain that. So our test is between 120 and 50. And notice it gives you the fits allocation right away, as well as down below is the summary of the test, which is your sample size, the fit allocations for each test, and the total fits, as well as your test parameters that it's using, like in this case the HTOL, high temperature operating life, activation energy. We were going to use 0.7, so you can override that down below and put that in. Here's the H2L. We can override that with 0.7. This is the override area, and then the qualification test planning will be with that. So now what have we done? We have a test plan now, even though we haven't introduced it yet. Here are the process cards for each. Here's a process card for the semiconductors. Here's the process card for the hybrid, and here's a process card for the assemblies. And these process cards have a lot of intelligence on how to do the test per a lot of the standards like JEDEC, and the science that we've introduced here that we discussed. And if we go down to the bottom, let me just show you what the test plan looks like. So this is the test plan for the semiconductors, and as well as there's a test plan for the hybrid area. Scroll down to that. As well as there's a test plan for the assemblies, which is the next process card over. That's here. There's a test plan for hybrids. And notice the groups are provided for that. Okay, I had to activate something, but I just did that. So the cards are now populated with the sample sizes. So you can see the sample sizes for each square here, and the summary is right for convenience is also provided here. The details of this test, for example, on the hybrids, on the assemblies, look at the assembly details that are provided here. It gives you the total sample size here, the control group that is requested once for that, the physical integrity test, ESD testing, destructive physical analysis, as well as it gives you the JEDEC specs or whatever spec we're using for that. Then this is the details of the test. Anybody, once this with this process card, anybody can perform the test. You can so the lab can do that once you have it printed out like this, and you can copy this and you can make alterations if you want to make some alterations for that. So it's very straightforward to do that. The accelerated test is split up here for each one, so it tells the laboratory how to split it up and start to perform the test. And it's not only is the process card provided to run the test, but also the expected conclusions are provided in DfRSoft for the for the qualification and what you've achieved if the accelerated test is performed successfully to the number of failures that you expected or allowed for the test and to the level of failure rate that you're interested in, or MTBF, that you're trying to verify. So there you have it. A lot of intelligence there to help you get doing your design assurance and your qualification test plans. And we wanted to show you the importance of how easily it is to do qualification test planning in any operation in DfRSoft. A lot of people are using this software to help them do design assurance. And like I said, we believe in the theory of everything, so that you have the tool right there and you can do all the design assurance tasks that you need to do intelligently, and also the things that you don't know how to do, you can learn quite quickly in DfRSoft because we have a lot of instruction videos like this one, and you get all the pop-up instructions, and it's a very friendly software. Anything you can do in Excel, you can do in DfRSoft, like graphical analysis. You can always change the graphs and the Weibull plots, for example, and stuff like that. So it's incredibly friendly, and we hope you'll give it a try, so you'll have an opportunity to make your product the best possible product you can. Thank you for